Welcome everyone to this week's Science News. In today's episode, we'll talk about the recent nuclear fusion headlines, a new result from the Webb telescope. Then we'll have a special guest, Fraser Cain, who'll tell us what we learned from NASA's Artemis mission. After that, we'll talk about remote-controlled magnetic slime, why atmospheric methane levels increased during the COVID pandemic, non-fogging glasses, algae that might replace beef, the toughest material on Earth, self-organized nanobots, dark photons, and of course, the telephone will ring. The National Ignition Facility has for the first time reported net gain in a nuclear fusion reaction. They fired almost 200 lasers at a small golden cylinder, inside of which there's a tiny coated pellet of hydrogen isotopes. The lasers heat the surface of the hydrogen pellet until it becomes a plasma, which in turn produces X-rays that attempt to escape in all directions. All this radiation is then pushing on the pellet until it implodes. For a fraction of a second, pressure and temperature increase so much that some of the hydrogen nuclei fuse and create helium. This creates energy the same way that our sun does it. Here are the numbers. The lasers deliver 2.05 megajoules of energy to the target, 3.15 megajoules came back out. The ratio of the energy out over energy in is called the gain, so that's a gain of about 1.5. 3 megajoules may sound like a lot, but it's really only enough to boil a few kettles of water. Most importantly, this gain doesn't account for the energy that's needed to run the lasers. It only counts the energy that the lasers delivered to the target. The total energy that's needed to run the lasers is around 400 megajoules. If you take this into account, then the energy they produced is less than 1% of the energy they consumed. What does this all mean now? First of all, it's a remarkable experimental achievement and all, but not really surprising. Last year in August, the NIF reported a gain of 0.7, which was getting close. In the coming year, they'll probably try to reproduce this experiment, and we'll see how reliably they can achieve net gain. This will tell us a lot about just what it takes to implode this pellet and how to control the explosion. But it's a very long way from there to feeding power into the grid. As we just saw, they'd have to increase energy output by more than a factor 100. Also, they'd have to find a way to dramatically shrink the cost for this to make commercial sense. So this is an interesting result from the scientific perspective, but it'll not have any practical use in the near future. To put this result into larger context, the method that the NIF uses to achieve fusion by firing lasers at a target is called inertial confinement. The competing method is called magnetic confinement, and it's how tokamaks and stellarators work. So far, there hasn't been any demonstration of a plasma gain for magnetic confinement. The record is held by JET, the Joint European Torus, and it's about 0.7. ITER is supposed to improve on that. Part of the issue with the low efficiency of the NIF lasers is just that it wasn't built to be efficient. It's a fairly old and big system. Changing much about its efficiency is basically impossible, and that was never its goal. If you want efficiency, you'll have to keep an eye on startups. For example, the British company First Light Fusion uses a similar approach, but they don't shoot with lasers but with projectiles. This is definitely a company to have an eye on. And while we wait for fusion power to save the world, I hope that someone figures out how you get more energy out of YouTube than you put in. New data from the Webb telescope confirms that something is wrong with our understanding of the universe. For the past 5 years or so, cosmologists have been worrying about a discrepancy in their data known as the Hubble tension. The Hubble rate measures the current expansion of the universe. The issue is that different measurements of the Hubble rate give different results. If our model for the expansion of the universe was correct, this shouldn't happen. A letter that was recently published in the Astrophysical Journal looked at some of the data which contribute to the Hubble tension. These are data of a class of extragalactic variable stars that were previously observed with the Hubble telescope. The same stars were now also observed with the Webb telescope, but at a better resolution. The data from the Webb telescope agrees with that from Hubble, which rules out the possibility that there was an issue with the Hubble data, so it confirms the Hubble tension. I found it interesting how the opinion about the Hubble tension has slowly changed in the community. Initially, a lot of astrophysicists thought that it's an issue with one or the other experiment or data analysis. However, most of those issues have now been checked, and the evidence has become increasingly solid that it's really a problem with the model, not with the experiment. What do you think, Albert? Is this going to shake things up? Whatever happened to that NASA rocket that went once around the moon? Fraser Cain is here to fill us in.
Thanks, Sabina. All right, you've probably heard that NASA's Artemis 1 mission is over. So let's take a look back at what happened, what was accomplished, and try to see what comes next. NASA's Space Launch System lifted off on November 16th, 2022. It was the first test of the core stage, as well as the attached solid rocket boosters, with the Orion capsule on top. This was planned to be an uncrewed mission, so no humans would be on board, but it would test out how well the spacecraft would perform in the real conditions of spaceflight operating around the moon. The liftoff went perfect, smoothly, no problems. The solid rocket boosters detached from the core stage detached from the upper stage, and the Orion capsule and its European Space Agency service module began their flight to the moon. The spacecraft did a flyby of the moon, coming within 130 kilometers of the surface, and then flew out to the farthest distance that a human-rated capsule has ever been. I have to put a quick disclaimer. There was the Apollo 10 Snoopy capsule that's orbiting somewhere around the sun, but back to Orion. The spacecraft tested out the navigation system, its ability to fly in various different modes, tested out its power generation, its electronics. It had 16 cameras installed on the solar panels as well as inside the spacecraft. And it also tested out the radiation load, both on the spacecraft as well as on the simulated astronauts inside, gathering all of the data that NASA would need to figure out what kind of an impact this kind of spaceflight would have on astronauts. Then it fell back down towards the moon, made another flyby, again coming within about 130 kilometers of the moon, and then fell back down towards the Earth. It detached from the European Space Agency service module and then entered the Earth's atmosphere and performed an atmospheric skip maneuver, where it bounced once out of the atmosphere and then back in to bleed off more of its velocity. As it fell through the atmosphere, its heat shield raised the temperature of the exterior of the spacecraft to about half the temperature of the surface of the sun, and then it landed safely off the coast of Baja California and was recovered by NASA. At this point, NASA is studying the spacecraft, looking at all the pictures, all of the data, and I'm sure we're going to find out a lot more information about how that mission went. But what comes next? The next mission from NASA is going to be Artemis 2, and that will carry 4 actual human beings on a flight around the moon. It will be a free return trajectory, testing out how the Orion capsule can keep 4 astronauts alive for several weeks. When that mission is complete, then we get Artemis 3. And that will be the first time that humans set foot on the moon in over 50 years. Once again, Space Launch System will launch an Orion capsule. It will meet up with a SpaceX Starship lunar lander. 2 astronauts will climb on board, go down to the surface of the moon at the moon's southern pole. NASA has already announced 13 possible landing sites, so we'll find out what that final landing site will be in the coming years. NASA has ordered core stages for Artemis and new rocket engines all the way up to Artemis 6, and they've ordered Orion capsules all the way to Artemis 8, which would carry them through to the 2030s. So if all goes well, we should see Artemis 2 happen in the next couple of years, 2024, 2025. But NASA aren't the only people who are planning on sending humans to the moon. You've got the Chinese who have their own human space exploration plans for the moon, as well as SpaceX planning to do its own private missions to the moon. And there are other various groups considering the moon as well. So we should see the moon become a fairly busy place over the coming decade. Now, I've done a deep dive into the entire Artemis mission, so if you want more information about that, you can check that out on my channel. But this is Fraser Kane reporting for Sabina Hassenfelder. Back to you, Sabina.
Scientists from the Public University of Navarre in Spain have demonstrated a kind of programmable matter that can be remotely manipulated using heat and magnetic fields. The composite they used is a mixture of a thermoplastic and some iron powder. The plastic is rigid at 27 degrees Celsius but softens as it gets hotter. The iron powder reacts to magnetic fields, which makes it possible to change the shape of the material. The researchers used a laser to heat the plastic in a particular area, then switched on a magnetic field, causing the composite to bend along the line left by the laser into a new shape. When it cooled down again, it was completely solid and capable of bearing heavy weights. And while that's pretty clever on its own, what's also remarkable is the amount of control the researchers demonstrated over their wireless programmable matter. While it's hard to form small details, the team was able to show that by heating the plastic at specific points and then using the magnetic field to raise the surface, they could form a large variety of shapes by melting, stretching, rotating, and contracting the material. It doesn't have to be lasers that heat it up either. The team showed that the material could be heated using infrared light or microwaves. This makes it possible to manipulate the shape of the objects while inside biological tissue. The researchers say that this is a potential new technology for medical implants and other biomedical devices. I think it actually doesn't matter if it's useful, it'd be on every 10-year-old's Christmas wish list. During the COVID lockdowns, the concentration of methane in the atmosphere mysteriously increased. According to a new paper that was just published in Nature, part of the reason was that car emissions went down. Yes, down. Methane is a potent greenhouse gas. Even though it decays much faster than carbon dioxide, it's much more efficient at trapping heat. Methane is usually scrubbed out of the air by a reaction with hydroxyl radicals. That's molecules containing one hydrogen and one oxygen atom. When they react, hydroxyl radicals and methane produce water and carbon dioxide. The authors of the new paper found that about half of the increase in atmospheric methane in 2020 was due to the warm and wet weather in the northern hemisphere. This increased methane emissions from wetlands, especially in the Arctic. The other half of the methane increase, they say, didn't come from emissions. It came from a decrease of hydroxyl radicals in the atmosphere. And why did that happen? These radicals are produced from nitrogen oxides and carbon monoxide, and one of the major sources of those is the burning of fossil fuels, for example in gasoline-powered cars. And what did we do during lockdown? We stayed at home, or at least we were supposed to. So, less travel means less nitrogen oxide, which means less methane is cleared out from the atmosphere, and it's not a small effect. I have a feeling that this paper is going to be somewhat controversial. Mr. President. No, they looked into it and found that sending fewer emails will not save the planet. But, if I may add, it might make the planet worth saving. Always at your service. Your breath is warm, your glasses are cold, and the result is fogged up lenses. And as we've found out during the pandemic, wearing face masks makes it much worse. Now, scientists from ETH Zurich say they have solved the problem. Their solution is solar-powered. It's a thin layer of metals that absorbs infrared radiation from the sun, which causes the glasses to heat up. The heating drives off the moisture, which causes the fogging to clear. The metal layers are made of thin clusters of gold that are sandwiched between layers of titanium oxide. The entire coating is just 10 nanometers thick, and it doesn't absorb light in the visible part of the spectrum, so you can see right through it. As you can see, in their tests, this worked pretty nicely. The coated glasses don't fog. Ingenious! Now, if they could just stop them from slipping down my nose. Do you want algae with that? The thought of tucking into a plate of green pond slime may not be particularly appetizing, but new research from Reichman University in Israel says algae are the future of nutrition. The news comes after an early analysis of a biotech system in Iceland that produces spirulina, a blue-green cyanobacterium that's perfectly edible. According to the new paper, eating a kilogram of spirulina instead of beef would save almost 100 kilograms of greenhouse gas emissions, 1,400 liters of water, and free up 340 square meters of land. The algae don't have to be eaten as a dripping green mass fresh from the nearest pond. They can be used as an ingredient in pasta or pancakes, dried into a powder, consumed as a paste, or even popped as a pill. I'm sure you can also use it for purposes that don't begin with a P. Aside from being less damaging to the environment, spirulina is highly nutritious with around 60% protein, along with vitamins, iron, and essential fatty acids. It's so useful the European Space Agency is considering it as a food supply for future Mars missions. If that's the future of nutrition, I think we'll have to wait for the future of marketing to catch up first. Scientists have measured the new toughest material on Earth, narrowly beating 5-year-olds who really want that candy bar. The toughest material yet discovered turns out to be a simple metal alloy, according to a study that was just published in Science. A group of American scientists blended chromium, cobalt, and nickel to create an alloy that's both malleable and strong. That's already unusual in metals, where you normally either get one or the other, but not both. More unusual still, both these properties improve as the alloy gets colder instead of it becoming more brittle. The new material is known as a high-entropy alloy, which means that instead of being mostly one type of metal mixed with smaller quantities of the others, it's made up of an equal mix of its 3 constituents. When cooled to about 20 degrees above absolute zero, the alloy becomes 5 times tougher than the strongest steel. Understanding the properties of these high-entropy alloys could lead to new materials suitable for use in the cold of deep space or even high-altitude aircraft. You don't need to be living to exhibit intelligent behavior, it seems. Researchers from Penn State and Ludwig Maximilian University have created a computer model that describes how systems form complex structures, whether they're technological or biological. In this model, the bots can process signals, which allows them to communicate and respond without external guidance. That way, they can self-organize and form complex states similar to living systems. As individuals, each entity has no intelligence, but as a self-organized collective, it can display behavior that appears intelligent and is capable of responding to its environment. The scientists hope that the research could lead to groups of nanobots the size of a living cell that self-organizes inside the body for medical interventions, such as virus hunting or drug delivery, or swarms of autonomous nanobots that can organize to create electronic circuits. What could possibly go wrong? A new paper in the Physical Review Letters looks into the effects of dark photons on the intergalactic medium and claims observations are compatible with the presence of such dark photons. Dark photons could make up dark matter. They are massive photons that do not directly interact with any light sensors that we normally use, whether that's eyes or cameras. The only thing they do is that they can mix into normal photons. That is much like neutrinos can mix into each other. Basically, their amount is not conserved, so it oscillates back and forth from more of the one to more of the other as time goes on. Besides that, dark photons have a gravitational pull, so they are one of many hypothetical particles that can make up dark matter. The intergalactic medium is, as the name suggests, stuff that lingers around between galaxies. It's mostly made up of gas of light atoms, hydrogen and helium, and small amounts of heavier stuff and dust. Data from the Hubble Space Telescope seems to indicate that this intergalactic medium is warmer than expected from the standard model of cosmology. The new paper now says that this might be due to dark photons. That's because the oscillation into normal photons can become enhanced in a medium, and that deposits energy into the medium. They say that the mass of those photons that fits best to the data is about 8 times 10 to the minus 14 electron volts. That's incredibly tiny, more than 100 million billion times smaller than the mass of an electron. What does that mean? Nothing really. There's a long history of previously unexplained astrophysical phenomena that particle physicists have tried to explain with new particles. Each time something is a little too bright or a little too hot, it's allegedly some sort of new particle. All these observations have so far eventually been explained without new particles, and I think this is how it'll go for this one as well. I hope you're enjoying our science news. We'll take a break for Christmas and New Year. The next episode of our Science News will run on January 11th. I don't know what you'll do during the holidays, but I like learning something new. Something that's totally different from the stuff that I normally do. And this year, I've set my eyes on Brilliant's course on computational biology that covers genome reconstruction, sequence alignment, RNA folding, and many other topics that I want to understand better. I'm sure Brilliant has something for your interests too. Brilliant offers courses on a large variety of topics in science and mathematics. It's an amazing tool for learning, and they are expanding their content each month. Whether you want to brush up your knowledge on algebra, understand neural networks, or figure out how cryptocurrencies work, Brilliant has you covered. All their courses come with interactive visualizations and will challenge you with questions, so you can check your understanding right away. I like looking up things on Brilliant, and now even have my own course on Brilliant, which accompanies my videos on quantum mechanics. This course will introduce you to quantum mechanics starting from the very basics, so you don't need to be an expert already to understand it. My course gives you an introduction to interference, superpositions and entanglement, the uncertainty principle, and Bell's theorem. If you're interested in trying Brilliant out, use our link brilliant.org/Sabine and sign up for free. You'll get to try out everything Brilliant has to offer for a whole week, and the first 200 subscribers using this link will get 20% off the annual premium subscription. Thanks for watching. See you next year.